Hi, in this video, we will see a demonstration of core hoop principles. We'll start by creating a simple zoo management system in Java without applying any hoop principles like abstraction, polymorphism, inheritance, or encapsulation. This way, we can see the challenges of managing data without object-oriented programming feature. So for the non-hoop approach, I'll have a class named zoo management system. And I want this class to do two things. One, to store the list of animal names. And second, to display the list of animal names that got stored. So for the non-hoop approach, I'll have a class named zoo management system. Inside this class, I'm storing a list of animals' name in an array and not using collection size of 3. I'll declare a string array called animals with a size of 3 where each index will store one animal name. Now that I've added the size of animals array, I'm going to add animals to it. So for the animals array of index 0, I'm going to add lion. For index 1, I'm adding tiger. In index 2, I'm adding elephant. Second, I want to display the animals that got added to the array. Now if you look at it, all of this is done inside the main method directly with no additional structure. In displaying animal part, what I'll be doing is I'll be using system.out.println and for each loop to print each animal present inside the animals array. Let's try running this code to see the output. We can see lion, tiger, and elephant has got printed as expected. Now in this first approach, we didn't use any of the object-oriented programming principles. I'm going to comment this non-hoop approach and let's go for the hoop approach. The previous version works, but it is not using any OOPS principles. To refactor them into the OOP principles and improve the design, first let's define an animal class. I'll add a private animal name and parameterized constructor to set the animal's name. So now I have defined my animal class. I'm going to make it abstract so that any class that is going to inherit this class has to implement the methods inside them. As they are abstract, there is no way that an object can be created for the animal class. We do have to extend them into a new class so that we can create object for the new class that we are extending from them. So let's create classes for specific animals like lion, tiger, and elephant, and each of these will extend the animal class. In each class, I was using constructor to pass the animal's name to animal using the super keyword. The next step is to add a zoo class for management separately. So let's create a class for zoo as well. I'll declare a private animal array to store animal objects and a count variable to track the number of animals. Now in a constructor, I'll initialize the animals array to specific size of 3. Next, we'll add an add animal method to add animals to the array and print confirmation. Next, we'll add the display method in zoo to show all animals in the zoo. For this, I'll use for loop to print each animal's name by calling getName on each object. With the OOP setup completing, let's modify the main method. First, I'll create a zoo instance with a capacity of 3. Then I'll add animal to add lion, tiger, and elephant, and then we will try to display the animals to show the list. To display, let's call zoo.displayAnimals method. So previously we had this output. Now let's try to run the OOPS approach, which is, so we are able to achieve the same result by applying the object-oriented principles in Java. The summary of OOP benefit is, by applying OOP principles, we achieved several benefits. Like first one is, we had a dedicated animal class. We made our animal class as abstract. Then the zoo managed animals privately. You look, we introduced another class, zoo, to manage the animals, and that was managing privately. And we also introduced the concept of inheritance when we were trying to create lion, tiger, and elephant to inherit from the animal class. And in our main method, when we were trying to call this add animal method, the add animal method was able to recognize lion and tiger and elephant, which was the feature of polymorphism, where zoo class was able to handle different animals dynamically. Now, this structure proves the flexibility and scalability of the system, making it easier to add new animal types and manage zoo operation. Whereas in the previous method, this solution is not a scalable solution by doing all the operations within the main method. Whereas now, by adding abstract class, I'm able to define the animal's behavior, and from that, I'm able to also extend different types of animal and also implement the animal's basic feature by providing an extendable and scalable solution. So thanks for watching. Bye.